Welcome everybody. So recording another pre-calculus instructional video. So this video is going to look at transformations of functions, and we're going to talk about how the graphs of these functions will change based on how we add or subtract, multiply, divide, um, graphs reflecting, stretching, shifting to the left, to the right. So all those might sound familiar to you, and I hope they do. But we're going to break it down just to kind of quickly review how the transformations work. So for this particular video, we're going to start with just shifting graphs. So moving it left, right, up, down, and what transitions and what transpires in order to make those things happen. So let's go over to our graphing calculator, because we're going to do a little bit of exploring to see how this happens. Okay, so I have up here on the whiteboard is our parent graph. So remember that parent graphs are our most basic graphs. So a quadratic, absolute value of x, a linear graph, square root graph. So like very basic functions. We're not adding anything to it. We're not subtracting. We're not multiplying anything by it. We're just only using the function. Okay. So there aren't very many parent graphs. We're going to learn about some new functions this year because this is pre-calculus and we're going to do some trigonometry. So we're going to see how those same types of things are going to happen in terms of moving the graph left, right, up, down. It doesn't matter what the function is because we're just doing is a transformation. So I'm using x squared here as an example. So you can see that I have as a blue graph. So for right now, let's just show our red graph, and I'm going to adjust this here to make it a little thicker so you can see. So there's my quadratic, and now I'm going to graph x squared plus c. So you can see that I'm going to set right now c to be 0. So I can see capital C is 0. So I can see it's right on top of the other graph. So it's really no different. But what if I were to say x squared plus 1? So I'm just kind of moving my slider here. So now you can see it moved the graph up 1 unit. Okay, so I can literally see that the vertex is no longer at 0. It moved up to 1. The whole graph, in fact, everything moved up to 1. So again, I'm going to show you. So here it is at 0. And when we added 1, boom, it jumps up there. Now, what if I were to increase the number? What if it were 2? So if C became 2, it moved up 2 units. So it looks like if the more I add, the more the graph moves up. So I see C3, C4, and I'm going to zoom out so we can see the rest of this. 6, 7, 8. So the graph will move up based on how big C is. If I go the other way, if I make C negative, then what happens? The graph moves down. So -1, -2, -3, -4. I see that the graph is moving down. So the important thing to note here is that the shape of the graph is not changing. We are literally taking that red graph, our base graph, and I'm just shifting it down 4 units. It's not that it's stretching or being distorted. It's being totally slid down the axes so that it is at 4 units. So we see that when we add or subtract to the function, that causes our graph to move up or down. Okay. Now I'm going to switch it up. So now I'm going to include this purple graph. So now notice how this one's different. Now I'm adding, but I'm adding inside the function. So I'm not adding outside the function like we did with C. I'm adding inside the function, which is this variable d. So now, based on what we saw earlier, we would think, well, I'm going to add. So if I make d +1, I think the graph's going to move to the right 1 unit. Well, let's see if that assumption is true. If I make it positive, whoa, it didn't move to the right. It actually now moved to the left. Let me show that again. So it's 0, and then if I make it 1, it moved to the left. So why is that? Because we are changing the value of x. We're adding 1 to my x value before I carry out the function. So it's really kind of grabbing the answer from before. So at 0, before the function should have been equal to 0. That's what the parent graph says. But now, what happens when x is 0? You added 1 to it, so you're making the answer now be 1 squared. So it's taking the answers from earlier. So at 0, it's looking like here, the answer at 1, and it's pulling it over here. And it's doing that for every single point. So the more I add inside the function, the more the graph moves to the left. It's not moving to the right, it moves to the left. So it's actually doing the opposite of what we saw C do. It's moving it in the opposite direction. So if I were to subtract, so -1, -2, -3, now notice how the graph moves to the right. So when we add inside the function, it's actually doing the opposite. When we're adding outside the function, then it's kind of running to what we would think would happen. Plus is up, minus is down. But when we add inside the function, it's going like in the opposite direction. If I add, it's really going to move to the left. Versus if I subtract, it's really going to move to the right. Okay. So let's see is it just this function or does it happen with every single function? So now let's go ahead and we'll look at, let me show that one. Let's go ahead and let's look at another base graph. So I'm going to look at our absolute value graph. So again, I have the same setup here as before. So I have absolute value of x, and this time again, I'm going to add on the outside of the function. So the function is different, totally different function, but does it do the same behaviors? So again, if I make c positive, I'm adding outside the function, it should move up. Does that happen? Yep, it's moving up. I see that the more I make c positive, the more it's moving up the graph. And if I make c negative, it should move down the graph. Sure enough, it does. So it looks like it's doing exactly the same thing as before. All right, what about D? So now let's look at D. D, again, our purple graph. Now, we saw that with the quadratic, that if it's positive, it's going to move to the left. It's going to do the opposite of what I expect. So let's see if it does the same thing here. So if I make D positive 1, I'm expecting the graph should move to the left 1 unit. So let's see. Yep, it did that. So it's doing exactly the same thing as we saw with the quadratic, with x squared. It's doing the same exact behavior. So if I make it negative, so if I make D -1, -2, -3, etc., it should move to the right. Yep, I see that happening too. So it doesn't matter what the parent function is. All that matters is the transformation. The transformation is going to cause the graph, regardless of how it's shaped, regardless of what function we're looking at, it's just going to cause the graph to either move up, down, left, or right. To further illustrate that, and I kind of let the cat out of the bag a moment ago, is looking at this. So here's this red function, okay? So here's this red function, f of x, okay? Now notice there's sine, there's x squared, there's a 3x. Forget about all that. We have a function. This is now our parent function, okay? Now, they are using different letters. They're using x and they're using h and k. So what effect, our first question is, what effect does k have on the function g of x? So I'm going to go ahead and set these to 0 like we had before. So g is a transformation of f, okay? So let's first look at the k. So this is happening outside of the parent function. So all of this is f of x. Notice this k is outside the function. So this is just like what I had earlier here with that plus c. It's outside the parent graph. So what do we think is going to happen? If I make k positive, the graph should move up. See, yeah, it moves up. The shape of the graph doesn't change. It's just that it's moving up. No matter what k is, as long as k is positive, we're moving the graph up. If k becomes negative, what do we think the graph's going to do? It should move down. And sure enough, that's exactly what the graph is doing. It's moving down. It's not stretching. It's not getting distorted. It's just literally shifting the graph down the more I make k negative. All right. Now, what about h? So now h is inside the function. So what did we see happen? H. Now notice this time, it's not a plus, okay? It's a minus. So we're subtracting. So remember, it's always going to kind of do the opposite of what we think. So if h is positive, according to what we have here, if h is positive, it's really what? Because we're subtracting, it's really negative. So just to make things a little easier to understand, I'm going to come back in here in this, for our function, just to kind of match up what we had earlier. I'm going to put it as this. Okay? All right, so now, what do we think is going to happen? If h is positive, we're going to add a positive number. Remember, it's going to go in the opposite direction. So I think that if h is a positive number, it should move to the left. Let's see if that holds. Yep, it's moving to the left. The more I make h positive, the more it's sliding to the left. It's getting left behind. If I go now and I make h negative, it should move to the right. So again, the red is our parent. The orange is our transformed graph. So we see no matter how complicated our parent graph is, if all I'm doing is graphing a transformation of that, then I know what that's going to look like. It's the same shape, it's the same graph. We're just moving it to a different point on the grid. All right.